Hello everyone, in today's video we are discussing about the Schmitt trigger. So Schmitt trigger is nothing but a comparator which is having a positive feedback. Previously when we seen peak detectors and op-amp, we were having positive feedback. If we required we were taking, if we were not required we are not taking. But here this comparator is with positive feedback. We can also say Schmitt trigger is a regenerative feedback because the input wave will always converts it into the square wave or a rectangular wave. Bistable circuit is also a operation of a Schmitt trigger. So bistable circuit, what it will do, till you change the input waveform you will not get varied output. That means till we give another input or till we change any sine wave, we won't get different output, we'll get the same output. A Schmitt trigger circuit is fast operating voltage level detector. So peak detector was used for finding the highest peak level, but what Schmitt trigger is doing, it is a fast operating voltage level detector. Next we have the reference voltage is a positive when output voltage is very positive high. So whenever we have input has a positive, we are getting output is also a positive, which is under a positive saturation. That's why we are telling positive saturation. We are getting positive input, positive output. So when the reference voltage is negative, then output voltage is low. That means we are giving input negative and we are getting output also negative, which is in negative saturation. The voltage at which output switch from plus saturation, that is positive saturation, to negative saturation, that is plus Vsat to minus Vsat, we call triggering points. That can be upper triggering points or it can be a lower triggering point. And the difference between upper triggering point and lower triggering point is called as hysteresis. So Schmitt trigger we are going to classify in two forms, that is inverting Schmitt trigger and non-inverting Schmitt trigger. Let us see. So first we'll see inverting Schmitt trigger. So what is inverting Schmitt trigger? Inverting Schmitt trigger is nothing but we are having inverting terminal our input. So our inverting terminal is given input, and according to Schmitt trigger definition we are connecting the positive feedback has a voltage output. So the positive feedback is not connected to ground as we were connecting at peak detector. Here what we are doing, we are connecting this positive feedback to output voltage, and this part we can take this resistor which is connected to ground, we can take it as voltage reference. Next, how the sine wave when we are giving at inverting terminal, how it is generating the square wave, we'll see. So when we have given the sine wave, that is a input signal is given and it is starting at UTP level. So what is UTP level? So let us say this is a 0 threshold point, and upper the 0 we call this as plus Vsat, and lower this 0 point we call it as a minus Vsat, for example. So this UTP is nothing but upper trigger points, that is in plus V saturation. At till what time the sine wave can stay at that. So this is called upper trigger point and lower trigger point. So in inverting terminal what happened, when there is a positive sine wave, we'll get the output in negative form. When we have negative input, we'll get positive output. So input, if we are getting positive, output will be negative. If we are getting input as negative, output will be positive. So here when the sine wave is in upper threshold point, when the sine wave is in upper triggering point, what it is doing in square wave, it is converting into lower triggering point because it is in inverting terminal. So this is how the waveform will start. See here, when it is in positive input, we are getting output in square form as in the negative saturation, that is LTP, below LTP. When the sine wave is below LTP, we are getting the output in upper LTP. So here the input voltage Vin is applied to inverting terminal and feedback voltage will be given to non-inverting terminal, as I said. Let us assume that input voltage at inverting terminal is slightly positive than feedback voltage at non-inverting terminal. This will provide negative output voltage. So here we can say when the sine wave reach UTP, output will be negative. When sine wave reach LTP, output will be positive. If positive, that is it will go to UTP. This is in inverting terminal. And the voltage at non-inverting terminal, so we can take it as the voltage at non-inverting terminal input is given as, so V in is equals to, so voltage output across the voltage reference. So here we can say that the voltage reference, so the voltage reference is across the parallel voltage output. So we can say here V0 into R2, that is voltage across the reference resistor is 2 and summation of 2 resistor will get as voltage reference value. Now when the output voltage is saturated, so we can say when we are calculating for UTP, so UTP is nothing but plus Vsat into R2 divided by R1 plus R2, because this we are calculating for whole circuit, but UTP is only for saturation level, that is whether the UTP is in the total sine wave at that time it is in plus saturation level or negative saturation level. And next LTP equals to minus Vsat R2 divided by R1 plus R2. Next, what we have, and one more thing we know that the hysteresis voltage is nothing but UTP minus LTP. So we can equate equation 1 and equation 2. So we'll get R2 divided by R1 plus R2 plus Vsat minus of R2 divided by R1 plus R2 minus Vsat, which will give us, so Vsat, so we will get, what we'll get, we get 2 R2 by R1 plus R2 Vsat. So here we can assume that, so 2 into beta Vsat. So V hysteresis is equal to, so here we can take R2 by R1 plus R2 is equals to beta equation. Okay, so we are converting in beta. The hysteresis loop can be shifted to either 0 point by voltage connection. So we'll get as UTP equals to R2 into Vsat minus voltage reference into R2 whole divided by R1 plus R2 plus voltage reference. So here we can take the R2 common, so we'll get Vsat minus VR, that is voltage reference, R1 plus R2 into R2 plus VR. So we know that beta equals to, so Vsat into beta plus VR, R1 divided by R1 into R2. So this is the UTP value, and LTP value we can take it as, so LTP is minus beta Vsat plus R1 voltage reference R1 plus R2. So we'll get R1 plus R2. So transfer characteristics. So what is the transfer characteristics? So how we'll see transfer